Yo, welcome back. Still your boy Algebra, still in the studio, still hanging out with my man Big Av, sitting here in his little swing. Uh, but I want to talk to you for a minute about some story problems, substitution-based story problems still. And so that still means, just like in the first video, we're talking about two equations that have two variables each. And now I'm stepping up the difficulty quite a bit. The last couple of problems just talked about random numbers, talking about the wind, which was only like going one direction or back. But now I want to talk to you about mythological creatures. I want to talk to you about minotaurs and unicorns hanging out in the enchanted forest. There's 16 of those total. 16 animals, if you want to call them that. 16 magical beasts. These animals, they have 26 horns total. And I want to know how many unicorns there are. So what you need to stop and think about is, how many horns does a unicorn have? That's right, it's in the name. One. Come on now. So, the big idea is, now that we're talking about these two equations and two variables, you need to recognize that in this particular question, there are two situations. You have the count and you have the value. In each one of those, we have a relative ability to talk about minotaurs versus unicorns and the total. That means literally, as I'm walking down the street, if I just started counting the minotaurs and was like one, two, one, two, three, that means I'm just counting how many times I see the letter M versus the letter U. There have to be 16 of them. I told you that in the first sentence. The value equation. Now, the value is determined by what the story is actually about. So this is where you would probably start to use a label. I'm talking about horns. And both of these two things have a value that needs to be attached to them. The value of a minotaur, the number of horns that a minotaur has, is two, like a bull. For those of you who are not well versed in your mythological stories, the minotaur is half man, half bull. A unicorn is a lovely creature that farts out rainbows. Unicorns have one horn, and now I have two equations. That's all I needed. So again, what I want to try to do is set it up so either I get a variable by itself, or I can get the same equation, or excuse me, the same variable by itself in both of them. That's what I'm going to do, just because I want to be a little bit different for it. Okay. I'm going to solve the top one. U equals 16 minus M. If I solve the bottom one, U equals 26 minus 2M. In our very first way of doing a substitution problem, we talked about points of intersection. And in points of intersection, we said that if I have the same variable by itself in both equations, I can just make them equal to each other. So throw it back to about Halloween. And remember, you had the ability to set two equations equal to each other because they said the same thing. And this is all I have. Easy peasy lemon squeezy to solve that out. I end up with 10 minotaurs. But that's not what I asked you for. I asked you for how many unicorns there are. Just like in a point of intersection, once you get half of it, you need to plug it in to get the other part. For the unicorns, it's 16 minus the 10. There are 6 unicorns. Man, that was cool. That was a lot of information. We talked about the 16 minotaurs and unicorns, but we also had a whole separate equation to talk about the fact they had 26 horns. We're going to see the same type of thing happen in this next question. Here it is. Oh, Lil Av. Hey, what's up, buddy? Lil Av has 71 coins. There are dimes and nickels only. No quarters, no pennies. He has $4. I want to know how many dimes there are. And actually, you do have enough information for this problem. We just have to uncover what we're looking at. Here we go. In any problem that talks about coins, that same situation is going to be true. We need to have an equation for the count and an equation where we attach some value to these things. In this story, we have dimes and we have nickels. The total count was 71. The total value is $4. We just need to fill in the part that has variables. Counting, I literally just like separate them into two giant piles. I have a pile called D and a pile called N. D plus N equals 71. The value, and this is the important one that you need to know, how much is a dime worth? A dime is worth 10 cents. That is 10 cents per dime. So you attach the value to your variable. The nickels, 0.05 in. And that's one of the things that a lot of people are going to make a mistake on. A lot of people are going to put 0.5. That's wrong. That's 50 cents. You understand? We're talking about individual cents. That means we're talking about individual places that are in the hundredths. And then even more people are really just bothered by the fact that there are decimals in this at all. Remember, anytime you're talking about decimals, you don't have to keep them if you don't want to. Just like fractions. You can get rid of a fraction, you can get rid of a decimal. I could change this thing to move all of the decimals away to be in this equation. And I do that by multiplying everything in the whole bottom equation times 100. So essentially, the two equations that I want to use are here and here. The real setup for this is there. Substitution and elimination. You don't know how to do elimination yet, so you're stuck. You're stuck having to get one of the variables by itself first. And once you get that variable by itself, you can substitute it into the other equation. And once you've done that, you end up with an answer at the end of the problem. Hopefully you can do it just as fast as I can. The value of n is 62. 62 isn't good enough though, because I didn't ask you for the number of nickels that are in this problem. I asked you for the dime. For the dimes, there's only 9. One problem left to go in this particular examination of our story problems using substitution, which means two variables and two equations. I would hope that you feel a little bit more comfortable at this point. Challenge yourself. Maybe you should stop the video right now and see if you can set it up on your own and then listen to the explanation. If you're going to do that, go ahead, press pause. And welcome back. One number is 5 less than half another. That is an entire sentence. I'm going to leave it there. 3 times the first is added to 3 times the second. And I get 40. And I want to know what the numbers are. So here we go. One number is 5 less than half another. One number is x equals 5 less than. Remember our conversation earlier this week. If you do less than, then it has to be something minus 5. That less than part means it has to be second in that equation. It cannot be the beginning. There has to be something there first so that you can take it away. Half another number. Let's go with y divided by 2. That's how you do halves, is you do division. So here we go. Next question. It says 3 times the first number, 3x, is added to 3 times the second, 3y, and I get 40. That one was easy. But again, what you see here is that you actually have 2 equations. They have the same variables in them, and we need a single solution. Let's do some substitution. Take this, since the x is already by itself, plug it in right there. 3 times y over 2 minus 5 plus 3y equals 40. Distribute. I know you hate fractions, so you might as well get rid of them. My bad. Made a mistake. When you get rid of them, make sure you multiply everything. Combine your like terms. Move the 30 to the other side. And you get y equals 110 over 9. Slightly less than beautiful number. But that's okay. Not worried about that. What I am worried about is, can you use this to get your x value now? Coming all the way back full circle, final answer should be something coming from x equals 110 over 9 over 2 minus 5. Yikes. It's going to test your ability to understand how division really works. The 9 and the 2 go together. They are connected like peanut butter and jelly. That just makes it x equals 110 over 18 minus 5. Yeah. So if you ever have a fraction stack on top of another number, you just put the 2 bottom ones together. Get your common denominator. Do your subtraction. And if you get a fraction for an answer, you should always reduce it. It's a better habit than not. Final answers. Y is 110 over 9, and X regular 10 over 9. So I hope that you feel a little bit more confident dealing with these story problems. I didn't ever say that they were easy, but they are absolutely possible. Just take your time, use your keywords, understand that there will be 2 equations for every situation, not just one. And I hope you live your best life today. Peace.